Hi. So in the previous video, we have discussed about the Mealy machines and the Mealy machines. So what was the broad difference between the Mealy machines and the Mealy machines? So that was the difference of actually lambda. Lambda was the your output function. So in case of Mealy machines, your output function was Q implies delta. Okay, because your output is depending upon the state. But in case of Mealy machines, you have seen that your output is depends upon the transition, and which is written as Q cross sigma, and this will be implies to the output alphabet delta. Okay, so this was the broad difference. So in this video I will discuss about the example of Mealy machines and the Mealy machines. So let's begin. So in the first question you can see that you have to design a Mealy machines for the ones complement. Okay, so ones complement is not new to you, because you have studied this ones, how to calculate the ones complement in your previous classes. Okay, so let's say if you get 101, so your ones complement will be equal to 0, 1 and then 0. Okay, that means whenever you receive 1 you will produce the output 0, and whenever you receive the 0 your output should be 1. So this should be your ones complement. Okay, so your Mealy, in case of your Mealy machines, your output, your state is contain the output. Okay, so in this case we have seen that we have total how many number of outputs? We have two number of output, 0 and the 1. Okay, so for binary number you have not receive any other output. You will not produce any output, because you either you will get 1 or either you will get 0 as your input. Okay, so whenever you receive 1 you will produce the output V, whenever you receive 0 you will produce the output V. So you will have how many state in total? You will have two state. One is corresponding to your output 0 and other will be corresponding to your output 1. Okay, so let's say I am calling this state as Q and this state as P. Fine, so this is your, let's say, initial state, and let's say if you get 1, so what you will do for 1, you actually produce 0. So for 1, so you will be in this state and produce the output 1. So now let's say if you receive 0, you will need to produce the output 1, so you will reach to the next state which is containing the output 1. Okay, fine, so transition to this state is completed. And now see the transition for this state. So let's say you are in Q state and you receive 0. So what you will need to produce? You will need to produce the output 1. So you will be stay in this state on 0. And if you, let's say, receive 1, so what you will need to produce? You will produce the output 0 for 1. Okay, so this was your example for the case of your Mealy machine actually. Okay, so no problem in this case. So now my second example is for designing a Mealy machines to find the residue modulo 3 for binary number. So what is this residue modulo 3? So let's say this residue modulo 3 is actually your remainder function. Okay, so this will actually give you the remainder. So if you, let's say, receive 1, so you will need to produce the output, let's say, 0, and for 1 you will produce the output 1, and for 2 you will produce the output 2. Okay, and for 3 what you will need to produce? You will produce 3, because 3 modulo 3 will be equal to 0. Similarly 4 modulo 3 will be equal to 1. How? 4 if you divide 4 you will get the remainder 1 after dividing 3. Okay, similarly if you get 5, so 5 will not be divisible by 3, so you will get the remainder 2. Okay, so here I can see that I have maximum 3 number of outputs, so you can have 3 state in your automata, in your finite automata. So let's say this is your state Q and this is corresponding to your output 0, and there is one other state, let's say Q1, and the output correspond to this state is, let's say, 1, and there is another state which is having 2 and output corresponding to state is, let's say, 2. Fine. So I am created 3 states. One is for output 0, one is for output 1, and another is for output 2. Suppose that you are in this state. Okay, so whenever you receive 1, whenever you receive 0, so after taking the modulo you will get 0. So your output will be 0 if you receive the input 0. So let's say if you receive the input 1, okay, if you receive the input 1, so you will need to produce the output 1. Okay, so now let's say if you receive 2, your output should be equal to 2. So actually this is your binary number. Okay, so what is the binary number for decimal 2? So you will have 1 and then 0. So for this number you will get the output 2. Okay, so first you will receive 1, and then again what you will receive? You will receive 0. So you will need to produce the output 2. Similarly for 3, if you get 3 will be equal to 1 1. So your output will be equal to 0. So from this state you will receive 1 and then 1. So you need to produce the output 0. Okay, suppose that if you receive, let's say, 5 is actually equal to 1 0 1. Okay, so 5 modulo 3 will be equal to how much? Will be equal to 2. Okay, will be equal to 2. So you will receive 1 and then 0, and then you need to produce the output 2. That means you will stay in this state on receiving 1 after 0. Okay, similarly for this state, let's say you can have this state is completed. Okay, for transition 1 and the 0, this state is also completed for the transition 0 and the 1, and this state is incomplete. So you need to show the transition for 0. So let's say if you got the output, let's say input 4, okay, which is equal to your 1 0 0. Okay, so what you'll need to produce? So your remainder will be equal to what? Your remainder will be equal to 1. Okay, so 1, and then you will receive 0, and after that if you receive 0, your output should be equal to 0. Okay, so now this machine is completed for you. Okay, so you can also analyze this for another example. Let's say if you have 10, so 10 modulus 3 should be equal to what? You should get 1. Okay, so 10 decimal number in binary can be represented like this: 8 0 8 or 2 10 1 0 1 0. Okay, so 1 and then 0 and then 1 and then 0, so you will get the output 1. So you will be reaching the state Q1. Okay, so this was the example for residue modulo 3. I think these two examples are very simple example and very easily understandable. So let's move on to the Mealy machines example. Okay, so this was also very simple example in case of Mealy machines. So Mealy machines is actually depends upon the output. In case of Mealy machine is actually depends upon the transitions. Okay, so in this case also you need to find the ones complement of a binary number. So you have to design the Mealy machine actually. So what you will do? So ones complement concept is same. So you need to do for 0. If you get 0 as your input, you need to produce output 1. If you receive the input 1, and you need to produce output B. Okay, suppose that this is your state P. So let's say if you receive the input 0, what you will produce? You will produce the output 1. And if you receive the input 1, so you will receive the output 0. Okay, so now in this case you can see that Mealy machine can perform this ones complement operation using only one state. Okay, there is no need to create another state because my task is fulfilling in the one state only. Okay, now you can see the second question. Design a Mealy machine that produce output A whenever your input string contains 0 1, and output B if your input string contain 1 0, and output C otherwise. Okay, so let's begin with the example. So actually if you receive 1 0, so you need to produce the output B, and if your string contains 0 1, you need to produce the output A. Okay, if you receive, let's say, 0 or 1 or 0 1, so you need to produce the output C. That means if your input string is containing the substring 1 0, you will produce the output B. If your input string is containing the substring 0 1, you will produce the output C. Otherwise you will produce, let's say, if your string containing 0 or 1, so you will produce the output C. Okay, so first I am going to design the skeleton for 0 1 and for the 1 0. So what is the skeleton for it? So let's say this is your starting state, which is actually your, let's say, P state. Okay, so what you can do in this state for 0 1, for reading 0 1, what you can do, you can reach to some other state, which is Q. Okay, for 0, and then for 1 you can reach to the another state, let's say R. Okay, now for designing the skeleton for 1 0, what you will do, you can read 1 from P and you can reach to the another state, let's say PQRS, and then for let's say after 1 you may receive 0. So for 0 you can move to another state, let's say T. So this is your skeleton for this question. Fine. So if you receive, let's say, 0 and then 1, so you will need to produce the output A. Fine. If you receive 0, you will produce the output C. If you receive 1, you will produce the output C. And if you receive 1 and after that let's say after 1 you are receiving, let's say, 0, so you will need to produce output what? 1 0 for B. Okay, this will be equal to 1 0. 1 0, your output will be B. Fine, no problem. Now complete every state, transition for the every state. So for P, transition for 0 and 1 is completed. Now for Q, your, let's say, Q, the transition for 0 is missing. So let's say if you have input for, let's say, many number of 0, and then you may receive 1. So this string is actually containing the substring 1 1 0 and then 0 1. Okay, so whenever you receive 1 after a single 0, so you need to produce the output what? A. Okay, so for first 0 you will produce the output C, and then you can design here the self state. Okay, for 0, and for every 0 you can produce the output C. So for every 0 you can produce the output C, and then if you receive A, you can produce the output A, because your input string containing the substring 0 1. Okay, so now transition for this state is completed. So now see for it. Okay, so here what kind of string you may get? You may get like 0 0 0 1 or 0. After that you may receive 0, and then you can also have these kind of string, let's say 0 0 1 1 kind of string. Okay, or you may receive like 0 0 1 1 0 and then 1. Okay, so what you will do, you will read first 0 in this case, and then you can read many number of zeros, and if you find 1, so your input string will contain 0 1, so you can produce the output A. And after this 1 you are receiving 0, and you can observe that this string is also containing the output, the string 1 0, so you will produce then B. Okay, so what you can do here, so for let's say 0, you can move to the next state by producing the output, let's say output B. Fine. So after producing the output B, you can move to the next state, no problem. Now see, in this case, let's say for 0 you will produce output C, for 0 you will produce the output C, and whenever you see 1 after 0, so for 0 1 you need to produce output A, and then for after you may receive many number of ones. So many number of ones are not useful to us, so you can stay in this state itself. So you can produce the output C here. Okay, so these are the many number of ones and many number of zeros are not useful to us. Okay, so the transition for this state R is completed. Now see the transition for this state S. For 0 it is moving to the state C, and for 1, let's say if you are receiving many ones, so many ones are not useful to us, so you can produce the output C. Fine. Similarly, you can complete the transition for T. So here, let's say you are reaching by 1 0. So after 1 0, you will produce the output B, and let's say after reading 1 0, you may get 1. Okay, so this string is containing 1 0 as well as 0 1. Okay, so for first one you will output the C, and for 0, so this string is containing 1 0, so you will produce the output A, and after that you can observe that you will receive 1, so this string for 1 0 it will produce B. Okay, and after that you may get 1, so you can produce the output for 0 1, that is A. Okay, so that means from here you can move to this state, and you can move by this this input, and you can produce the output, let's say what, 1 0, that means 1, that means for 0 1 what it is 1 0, and then after that, sorry, I am considering the input for 1 actually, so u 0 1. Okay, so this transition will be should be for 1 slash, and then after reading 1, so you can produce A here, so this is A. Okay, similarly from this state you may receive input like 1 0 and then many number of 0, so reading 1 and then many number of 0, single 0, so you can produce the B as output, and after that if you receive many number of zeros, so many number of zeros are not useful to us, so you can stay here with 0 and you may produce the output C. Okay, suppose that, let's say now every transition is completed to every state, so you can see the example. Let's say if I have a long state, let's say 1 0 0 1 0 0 1 and then 0. Okay, so what will be the output corresponding to this state? So now for the first one you will produce the output C. For 0 after 1 you will get the output B, and from this state you can read 0 and can produce the output C, and if you receive 1 from this state, so you may produce the output A, because this string is containing 0 1, and after that if you receive 0 you can come back and can produce output B, because this string is containing 1 0 as substring, and then again you may receive 0, so you will produce the output, let's say C. Okay, and then suppose that if you receive the output input 1, so this string is containing 0 1, so on 0 1 from this if you read 1, so you will produce the output A, and then you may receive 0, so this string is containing 1 0 and you can produce the output B for 1 0. Okay, so this is very pretty understandable. I think all of you got my point. Okay, so in the next video I will discuss about the applications, limitations, advantages, and conversion from Mealy to Murray and Murray to Mealy. So thank you.